could send that to a queue, and that information is now received and updated. And so I'm manually updating it. It just could be a map. It could be a map of a list of a list of a map of a map of a string of a list of a map of an int. That's our customer demographics data. It could use messaging as well. As a matter of fact, that I'll show you at the very end of the class, how to actually do your own custom caching. All right, so that was a good tangent. Where in the world were we? Oh, my word. Let's see. Wow, we were way over here. Okay. Hey, what time, Usha, do we break? 11:15? 11? We're in trouble. Okay, so let's get to the point here. I love that tangent. I mean, that's really the point of a workshop, isn't it? Is for everybody to gain a real full understanding of these things. I hope we can get through all this stuff. But, you know, I love these tangents. I love these kind of questions. It's worthwhile to really gain a full understanding of these. But let's move on to our tests. That's where we were. How big should your service be? How many services should you have? I'm going to tell you that and have you do that yourself. So here we're going to go. Manoj, what does your service do? And Manoj says, Mark, we're on the same team. You know what my service does. I'm like, I know, Manoj. Just tell me. Verbalize what your service does. And Manoj says, you are so weird. Okay, fine, Mark. It does A and B and C. Let's see, it does D. And also it does E. In addition, it does F. And, oh yeah, and sometimes G. All you have to do is verbalize your service. This is cohesion verbally. What you're looking for are all those conjunctive words. And, in addition, also, sometimes. And every time you say an and. Now, maybe A, B, and C need to be done together, but not with D, E, F, and G. And that's when we get to see an observation to where we have the potential of taking a coarse-grained service and moving it to fine-grained. Notice I said potential of. The potential to. This is an opportunity to make it more coarse or fine-grained, but maybe not, because watch the second test. Second test is transactions, and so here's what happens. And so what's your name way over here? Vishal. Okay, so Vishal over here is this service. Vishal gets two pieces of information. He gets orange data and he gets blue data. Now, Vishal has the blue data. That goes into his database or his schema. But the orange data needs to be sent all the way over to Manoj over here, and Manoj needs to insert it into his database. This is how microservices works. The problem is we don't have an ACID transaction. Now, you had asked about transactionality. We're going to see that at the end of the class, or towards the end of the day. I'm going to show how to do transactionality. But the point is, we can't do a commit or a rollback. Now, we have things like sagas and LPS and all this, and we're going to talk about those, but we don't have a database transaction. And so the point is this. If your business owner, your product owner, the person of importance, business-wise, says, oh, no. The blue data and orange data can never, ever, ever be out of sync. You know, transferring money. I have a trade that I'm switching over to a certain trader, from one trader to another. I've got a claim in an insurance company that I'm moving from one field agent to another. No, we can never, ever, ever have that out of sync. There can never be money that didn't make the transfer. There can never be a claim that's floating out there unassigned. There can never be a trade that does not have a trader assigned to it. Never. And what is your response as the architect or developer? Oh, no. You don't understand. We're using microservices. You agreed to microservices. We have something called BASE, Basic Availability Soft State, Eventual Consistency. They'll eventually be consistent. Don't worry. It'll only take about a tenth of a second. And what's your business owner say? No. You don't understand. Those two can never be out of sync. If you're playing this game, it is a great indicator that you have gone too far in making your services too fine-grained. And as a matter of fact, service consolidation solves this problem. It's a great test. There are areas. We are most of us here are writing business apps. And so the point is we have levels of transactionality that are required. And so this is not our decision to make as an architect or a developer. It's a business decision. And so this is another test I use. If we start having transactionality issues, then it means we've made our services too fine-grained. But you know the best test of all? Choreography. Now let me explain choreography versus orchestration. They're both called inter-service communication. That means services talking to each other. Initial request comes in, it goes to you, and then you go over to this gentleman, and it bounces around. Now, if I were to say orchestration, what root word comes to your mind? Orchestration. What do you think of? An orchestra. Fantastic. Who is in the front of every single orchestra? Conductor. They wave the batons and make a lot of money. There's a conductor's bathroom back here, I found out. Yes. So anyways, no, it's not true, actually. Everybody's like, can I use it? No. Actually, it's just a rumor. But anyways, the point is, a conductor. And that conductor is conducting all the musicians to do things. When you think of choreography, what do you think about? What's choreographed? Dance. That's right. In other words, is there ever a conductor in a dance? Is there somebody right front there? No. The dancers, whether it's modern or classical dance, are all moving in conjunction with themselves, communicating with each other to form a beautiful dance. Choreography versus orchestration. Can you tell me where the conductor is here? That's a proxy, by the way. It's just a reverse proxy or forward proxy. It doesn't matter. It's just a proxy. Can you tell me where the conductor is? There isn't one in microservices. Now, right after lunch, I'm going to show you how to create one in microservices. That's why choreography is so popular in microservices. Now, we find is service chaining does not work really well, so we start creating orchestrators. It's called the service orchestration patterning. We'll look at it in detail on part 4. The point is this. Choreography. This is what microservices is actually supposed to look like. Individual, separately deployed, independent services. Not communicating with each other. You know what microservices look like when we implement it? It looks like this. It's one big ball of spaghetti monolithic mess in a distributed world. So, for the rest of the class, let's make the assumption that a RESTful call takes 100 milliseconds round trip. 50 milliseconds in latency to get to you, 50 milliseconds to get back. This works great. By the way, this is the customer profile. We upload our picture, my name and address. This is the customer wish list. This is customer preferences. This one's the customer comments. This one's customer payments, so on and so forth. Customer orders. Get all customer data. Oh, I hate those requests. Because everything was so nice until we get all customer data. Well, let's do it. Ready, set, go. Here we are. Ready? Watch this. Oh, by the way, I forgot about that. We just had a crash, didn't we? Oh, dear. That just crashed. Who is impacted, though? All of them? Wait. That was preferences. That was the payment service. It just crashed. Who's impacted? Just the payment. Just that one service right there. No one else is impacted. Everybody else is running just fine. There's 2 or 3 operations going into that service right there. It's perfect. Yeah, fault-tolerant applications. Boy, I'm glad we're using microservices. I didn't realize that crash was going to happen. So let's get back to where we were before. Now, what I want to we just had another crash. But everybody's talking to each other. Who's impacted now? Everybody. We see the first problem with inter-service communication. We just lost fault tolerance. We lost overall availability. Because services are all dependent on one another, all of a sudden, if we have this crash, look at how many services are chained and talking to that and dependent to that service. Whether we're using choreography or whether we're doing orchestration, it doesn't matter. The service went down, we need it. All of a sudden, all these other services go down. Okay, that's our first problem. There they all go. Crashes everywhere, yes. Okay, so now let's take a look at get all customer data. Now that our crashes are done, watch this. Are you ready? 10 microservices needed for get all customer data. 1/10 of a second for each of those hops. Ready? Go. There's hop 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. You see the second problem, don't we? Latency. You know, in our monolith, get all customer data. You know how long that took? 320 milliseconds. You know what it takes now? 1,320. We've just added 1 second. 3 times worse performance because of latency. As a matter of fact, what we're going to see in the communication patterns, my favorite section, is the fact that that is actually not 1,000 seconds or 1,000 milliseconds. It's actually 2,000. That request actually takes 2,320 seconds or milliseconds. Yeah. All right. What about this though? So we use gRPC. We do some performance tuning, service co-location, stuff like this. Well, let's try that request again. Are you ready? All right, so now we've improved our performance. 2, 3, this is going much faster. 4, 5, 6, 6, 6, 6, timeout. Oh man, we were almost there. What do? Sorry, error, try again. 1, 2, 3, 3, 3, timeout. Sorry, try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Timeout. This will never, ever, ever work. All right, so we've got error handling. All right. You know, it's interesting. This has actually given rise to a style of programming. Microservices, let me just tell you, we're going to see this throughout the whole class, is a game changer. It is really changing the way our organizations are structured and the way we program. This will never work, will it? You know what this has given rise to? Let it fail, return what you can, and keep on trying. In other words, if you want to see this in action, those of you with Netflix, now I have a huge My List on Netflix, huge, because I add movies to it and I never remove them. Talk about an expiry on a wish list. So, what happens? About 1 out of every 12 times, I go to Roku or I go to, generally not on Roku anymore, but definitely on my phone, and I go to the home page, and I don't see My List there. I see all the other lists, you know, recently added, new releases, you know, if you like this movie. I start scrolling down. It's like, what in the world did they do with My List? I want to see my movies. Scroll back up. Oh, there it is. I must have missed it. No. It was a timeout, number 6. Let it fail. Keep returning every list and keep on trying. That's why things like React and Angular are so popular in microservices, because these kind of frameworks actually allow us to do that subscribe kind of polling kind of model, basically the observer pattern, quite frankly, to be able to subscribe to a particular microservice, to say, keep polling, and when you get that information, push it up to me. I'm subscribing to you. I'm going to get that information. I can keep pushing it up. And so it's interesting. That's given rise to that, which is quite amazing. All right. You know, there's so many other issues associated with this. Testability, deployability, scalability, if I need to scale these out, dependency. Have I convinced you? We can go on for another half hour, but have I convinced you this is pure evil? Yes, thank you. It is. Don't do it. But here's the problem. You will always have some inter-service communication. It is just unavoidable. You'll always have it. But what we want to strive for is to reduce that. It's going to impact performance, scalability, availability, testability, deployability, you name it. Everything will be impacted. As a matter of fact, we started this whole section with how big should your services be? How many should you have? This is the best test of all, because if you have too much inter-service communication, it's a great indication that you went way too fine-grained in your services, and that service consolidation removes all these dependencies. These are the 3 tests that you can use. Notice the first one showed an opportunity to split, but you don't want to, because if we say, oh, well, if it's doing A and B and C and D and E and F, let's split it into 5 services, and then they all need to communicate with one another. And so it's just this rubber banding. But these 3 tests are really good ones for actually determining that right level. Okay. All right. And let me just do this last section, and then we'll go on a break, okay? Because this will take about 2 minutes. Because microservices, to kind of finish up this whole bounded context thing, is something called a share-nothing architecture. We don't want to share anything in microservices, whereas in SOA, we share everything. So, will you have some inter-service communication? Yes. You will. I was working with a team about a month ago, and I was kind of sitting back, and there were two gentlemen, and there was one guy who kept saying, no, we can't communicate between services. We can't. We're going to remove all, it won't perform, it won't scale, and he was insistent. And so everybody was struggling to figure out, well, we can't combine them because of another dependency. What do we do? And finally I said, well, Mark, what should we do? And you know what I said? Communicate between them. And he said, but we can't. We can't share anything. Absolutely you can. There are times when you do have to communicate between services to get each other's data, maybe to invoke some functionality, but it's mostly to get data. So understand that microservices is very theoretical architecture style. And what I'm going to try to show you is how to pragmatically bend those rules. Can you bend the rules? Absolutely you can. Because of this bounded context right here, it gives us the benefits of everything and the worst of everything. So share nothing architecture, including shared libraries. So here's a jar file or a DLL that has common code that we all need. Interfaces, abstract classes, calculators, formatters, all that kind of stuff. All the interfaces that we use. And everybody uses this. Here's all of our logging and security and all that kind of stuff, and everybody uses that. We eventually make a change right here to this custom library, and the problem is it could potentially break the entire ecosystem. Everything is tied to it. There's no bounded context here. I'm sharing code across 2,000 services. Well, Mark, version it. Right. That works most of the time. Now, here's the problem. Share nothing. I like to say share as little as possible. You will have some of these. I mean, look, we're coding an object-oriented programming. We do have interfaces, abstract classes, some level of reuse. Neil, in his keynote, did a wonderful job of showing us that reuse is abuse. Kind of that leads to, this is a prime example right here. This is hard. This is a paradigm shift because we have really been trained in microservices, or we have been trained in our careers to reuse everything in the world. When we embark on microservices, we have to reverse all of that thinking. There's no reuse here. But are we going to have some classes, logging, security, audit, interfaces, abstract classes, a calculator? Of course we will. But here's the point. Like inner service, we want to minimize these. Every time you have a shared library, every time you draw one of these lines, I don't know. Culturally, I probably shouldn't say this. I don't know. Let's see if you laugh. Every time you draw one of these lines, a kitten dies. No, in the U.S., we love kittens, and so it's kind of a joke. But anyways, bad things happen. How's that? So the point is, we try to minimize these. Here's a little tip I'll leave you with. Please, if you do anything for me as a result of this conference, do not create back-end shared or shared.jar. No, Mark said to minimize it, so we only have one jar file. It's called shared.jar. Please, no. It's much better to have 25 smaller jar files than one large one. Why? Versioning. How often is that shared.jar going to change? Every week. How many versions do you support? 4? Every month we're going to be deprecating a version. That's way too much churn. By the way, it won't work. So if I have 25 smaller ones, security.jar, how often does that change? Maybe once every couple of years. And what I do is I move the volatility so I'm testing less. And so the point is, do I need calculator.jar? No. You guys need it. We don't over here. And it reduces the churn of having to pay attention to versions and stuff. So anyways, that's and the only other piece that we don't share, of course, is the database. If we make a breaking change to a schema, let's say I've got 2,000 services and I've got 800 tables, and I make a breaking change to a schema, change in type, I've just broken 800 services. No, I'll just change them. Okay, can you imagine coordinating the parallel development, testing, release of 800 services because of a database change? No.
Question. So,
yeah.
That shared library that you're talking about, how to decide
Right, okay, so the shared library. And let's end with this question and take a break. How do you determine the size of that? Generally, I will use volatility. Well, functionality, but also volatility. In other words, when I say volatility, the frequency of change. Logging and security. How often do those change? Hardly ever. Now, would I keep those as two separate jars? Probably. But I try to, so here's a good example. Formatter. Formatter.jar. It includes all the formatting for date, for strings, for time, for anything. I will use the volatility. If that changes all the time, that's a good way of starting to split that up. Because think about it. If that jar file changes, format.jar, this is a great question. Format.jar. There's all our formatting classes for formatting everything. How often does it change? Well, you know, the date format stuff changes a lot, but the rest of it doesn't. Think of what I have to test if I make a change to that. I really should test that entire jar file, and I don't want to. By splitting up date format.jar from everything else, the only thing I ever have to test is date format. The only thing I have to version is date format. And who uses that? You guys right up here. And so it's a way of kind of decoupling that. Yeah, volatility. Code volatility really is the key on that. Yeah. Code volatility, meaning the rate of change of that code. And never say never. Always code will change, but how often? And we can actually look in Git. We can actually do Git commands to actually find out the last time it changed. Or project changes to that. Yep. Wonderful. Let's take a break. It is 11:01, so we have 15 minutes. Is that right, Usha?